High or low voltage at a control board's terminals can indicate underlying failures that demand immediate diagnostic steps. Measure voltage at the transformer secondary with a quality digital multimeter set to the appropriate alternating current range and compare readings to the manufacturer's rated secondary voltage written on the transformer label. A reading more than 10% above rated suggests a possible transformer overvoltage or a failing load regulator, while a reading more than 10% below rated points toward voltage drop from excessive conductor length, thin gauge wiring, high connection resistance, or a partially shorted circuit. Inspect wiring runs for length and gauge. Long runs with undersized conductors raise impedance and cause measurable low voltage under load. So calculate voltage drop using the conductor resistance and load current and upgrade to a thicker conductor if drop exceeds 3% for control circuits. Check all terminal connections and splices for corrosion, loose screws, or signs of arcing. Clean, retighten, or replace terminals, and use rated crimp connectors or soldered joints where appropriate, because poor connections often create intermittent high-resistance paths that mimic low-voltage conditions under load. Test the transformer under both no-load and loaded conditions. No-load readings can be slightly higher than rated due to regulation, but if loaded voltage collapses significantly, suspect internal winding damage or external overload and prepare to replace the transformer. Use an isolation transformer or surge protection device if you observe transient high voltage spikes. Document spike magnitude with a transient voltage recorder where possible to verify whether spikes coincide with switching events, nearby heavy motor starts, or lightning-induced surges. When diagnosing control boards, also inspect the board's input filter capacitors and transient suppression components for bulging, discoloration, or cracked solder joints, because failed filter parts can allow mains, transients, or create internal short paths that distort the apparent terminal voltage. Common mistakes include assuming a single multimeter reading proves component health. Solution: measure both no-load and loaded voltages, and perform voltage under expected operational load to reveal regulation issues. Another mistake is replacing the transformer without checking wiring resistance and connections. Solution: measure conductor resistance and inspect all terminals first, since correcting wiring or tightening connections often resolves low voltage symptoms without replacing hardware. A third frequent error is ignoring transient events and only checking steady-state voltage. Solution: use a clamp meter to observe current spikes and, if available, a transient recorder or an oscilloscope to capture brief, high-voltage events and correlate them with system activity. BigHomeProjects.com connects homeowners with screened local contractors who can test electrical systems, diagnose transformer and wiring problems, and perform certified repairs. The site also helps contractors find qualified leads and detailed project requests to match their skills with homeowner needs.